This video is on integrated to chapter 5, D-Day number 1. So on these first problems here, 1A through C, it's asking us to factor and use the zero product property. So the very first thing I need to do is get 0 on one side, everything else on the other side. So I am going to minus 10x from both sides. And I'm going to get 0 is equal to, and I'm going to write it in descending order, x squared minus 10x minus 24. And now I'm going to factor that. So what multiplies to a negative 24 and adds to a negative 10? And we have to really think about this because 6 and 4 multiply to 24 and add to 10. But those are going to be both have to be the same signs, but we need different signs. So since my sum is negative, I need a negative, and then I need a positive because a negative times a positive gives me my negative. So I really want a difference of 10, not a sum of 10. So instead of 6 and 4, this is going to be a negative 12 and a positive 2. So this is going to be 0 is equal to x minus 12 times x plus 2. So x is going to equal 12. That's going to be one solution. And x is equal to negative 2. That is our second solution. On letter B, on one like this, again, always the first thing I want to do is see, hey, can I factor something out of everything? I cannot. Then I'm also looking to make sure I have a 0 on the other side, which I do. So for this one, I'm going to do a box to diamond. So I have a 4x squared here, a 15 here. Those multiply to give me a 60x squared, and it has to add to a 9, actually combined to give me a negative 19x. So this is going to be a negative and a negative because I have a positive product and a negative sum. And I'm thinking 15x and 4x. So a negative 15x and a negative 4x. So I want to focus first on this, which is either going to be a 4x and a 4x or a 2x and a 2x. But because of the 15, I definitely cannot do a 2x and a 2x. So I'm going to have a 4x here and an x here. 4x times negative 1, x times a negative 15. So I'm going to get 4x minus 15 times x minus 1. And again, this is equal to 0. And then I'm going to solve these. So I'm going to set 4x minus 15 to 0. And I get a positive, whoops. I get a positive 15 over 4. And then I get x is equal to a positive 1. So I get a 1 and a 15 over 4. On letter C, this one's actually a difference of 2 squares. So this is going to be x plus 6, x minus 6. So I'm going to get x equal negative 6. And I'm going to get x is equal to positive 6. On this next section, number 2a and b, I'm trying to write the equation of this, and I want to find the a, the stretch also. So what I want to look at is I want to look for my x-intercepts because that's going to help me with my factors. So I know I'm going to have y equal a times, and because of the x-intercept, that's a negative 2, that came from an x plus 2. And my x-intercept of 3 came from an x minus 3. And then I need to find my stretch. So I'm going to use one of these points, any of these points. I'm thinking that the easiest one would be this one because I can put a 0 in, so that might make it a little easier for me. And when I do that, I'm going to put negative 6 for my y, 0 for my x. And when I, let's say 3. And when I work this out, I'm going to have -6 is equal to a times 2 times -3. So I end up with -6 is equal to -6a. So my a is actually a 1. So my stretch is a normal stretch. So my equation is going to be y equal 1, but I don't need to write the 1, times x plus 2 times x minus 3. That's an acceptable answer. Or I can work that out. And if I was to multiply that out, I'm actually going to get an x squared minus x minus 6. These are both the same equation. One's in factor form, one is not. On letter B, I'm going to do the same thing, but from a graph. So let me identify my x-intercepts. So I have at -2 and I have at -4. So that means I'm going to have y equal a times x plus 4 to get the -4 as an x-intercept, and x plus 2 to get my -2 as my x-intercept. And I'm going to try to use a point that I can identify nicely. So let's see, this point down here is do it in a different color. This point right here is -3, -1. So I can put that in for my x and my y. So I'm going to get -1 is equal to a times -3 plus 4 times -3 plus 2. So I'm going to get -1 is equal to a times 1 times a -1. So -1 is equal to -1a. So a is 1 again. Don't assume a is always 1 though. Okay, so that means my equation is going to be y equal 1, but I don't need to write the 1. X plus 4 times x plus 2. I can also multiply that out. And if that's multiplied out, I'd have an x squared plus 6x plus 8. I'd accept either one of those. On number 3, these ones we're going to be doing sine, cosine, tangent, or inverse sine, inverse cosine, inverse tangent. So if I'm here at this angle, this is opposite, this is adjacent. So if I think of SOHCAHTOA, I am dealing with opposite and adjacent. So opposite and adjacent is tangent. Now I want to find the angle. So I'm going to do tan inverse of opposite, which is 8, over adjacent, which is 9. Now, just knowing that tangent of 1 is 45 degrees, since I want to figure out tangent of 45 degrees is 1. Since this is a 8/9, which is less than 1, I know it's going to be less than 45 degrees. I'm just going to put this into my calculator and we have to do it on both now. So you can see what I'm doing. Okay. Now, if I'm doing it on Desmos, I'm going to come here to the wrench. And I want to come down here and make sure it's in degrees. Okay. And then I can do tan inverse of 8/9. And you can see it's 41.63 degrees. If I don't want to have to type that in, I can also come here to functions. And right here is tan inverse. And I can just use that. So I got 41.63 degrees. So 41.63 degrees. Now for the next one, here's my angle. This is going to be adjacent. This is going to be hypotenuse. So this time I am dealing with adjacent and hypotenuse. So I'm gonna be dealing with cosine. So I'm going to do cosine inverse because I'm looking for the angle of adjacent over hypotenuse is equal to, and so I'm going to do cosine inverse of 11 over 15. So cosine inverse of 11 over 15 is 42.83 degrees. Okay, just making sure I had it in degrees still. 42.83 degrees. On letter C, I'm trying to find a side this time. And so when I'm looking at this from this angle, this is going to be opposite. This is going to be hypotenuse. So if I'm thinking of SOHCAHTOA, I am looking at opposite and hypotenuse. I'm going to be doing sine. So I'm going to do sine of 61 degrees is equal to sine of 61 degrees is equal to opposite, which is x, over hypotenuse, which is 17. I am going to multiply both sides by 17. So I'm going to times this by 17, times this side by 17. So I get 17 sine of 61 degrees, and these 17s cross out. So I'm going to put that into my calculator. So 17 sine of 61 degrees, 17 sine of 61 degrees. And I got 14.87. 14.87. So this is going to be 14.87 is equal to x. On letter D, when I'm looking at this one, here is 9 degrees. This 5 is going to be adjacent. This y is going to be hypotenuse. So I am dealing with cosine. So I'm going to do cosine of 9 degrees is equal to adjacent, which is 5, over hypotenuse, which is y. I'm going to multiply this side by y and this side by y. I get y cosine of 9 degrees is equal to 5. I am going to divide both sides by cosine of 9 degrees. And when I do, I get y is equal to, and so 5 divided by cosine. So 5 divided by cosine of 9 degrees is 5.06. So this is going to be 5.06. Okay. In the next section, number 4, 60 dinners were ordered from the local Mexican restaurant. 20%, let me just kind of highlight some information. 20% of the dinners have red beans, while the rest have black beans. 42 of the dinners have the whole wheat tortillas. 6 have flour tortillas, and 12 have gluten-free tortillas. If a person is randomly assigned a dinner, what's the probability in percent of getting a dinner with black beans and flour tortillas? Okay, and they want us to draw a sample space, show the sample space in a tree diagram or an area model. So we have red beans or black beans. We have whole wheat tortillas, flour tortillas, and gluten-free tortillas. So I'm going to do a 2x3. This side is going to be beans. This side is going to be tortilla. And for my beans, I have red. I'm going to just put R for red and B for black. And 20% of the dinners have red beans. So this is going to be a 0.2, which means the rest 0.8. And I'm just going to circle those decimals so I can see them. Okay, for the tortillas, we're going to have whole wheat. So I'm going to put W for whole wheat. And 42 of the dinners have whole wheat. 6 of them have flour, 12 of them. So if I take 42 plus 6 plus 12, I get 48 plus 12 or 60 dinners. Okay, 60 dinners. So here I'm going to do 42 out of 60. For the flour, I'm going to have 6 out of 60. And I'll put G for gluten-free. That is going to be 12 out of 60. And if I change these to decimals, 42 out of 60 is really a 0.7. 6 out of 60 is going to be a 0.1. 12 out of 60 is going to be a 0.2. Okay. And you always want to make sure that these add to 1, which they do, and these add to 1, which they do. And then I'm going to multiply these together. And so I am going to get 0.14, 0.02, 0.04, 0.56, 0.08, and 0.16. And if I add the inside together, oops, wanted to shrink that. So if I add the inside together, just to make sure, let's see, let me spread this out a little bit. Okay, so if I'm adding this together, 0.14, 0.02, so So 0.14 plus 0.02 plus 0.04 plus 0.56 plus 0.08 plus 0.16. That should add to 1 also. Okay, so let's see. When I do that, 0.14, 0.02, 0.04, 0.56, 0.08, and so on, I do get 1. So you always want to make sure you get 1 before you figure out the rest of this problem. Okay, so what are we looking for? We're looking for someone who had a flour tortilla and black beans. flour, tortilla, and black beans right here. That's going to be 0.08, which is 8%. On number 5, we are completing the square and they want us to leave in an exact form. That means in a radical form. So if I'm completing the square, I am going to be having x squared minus 6x. I'm going to take the 9 to the other side. So that minus 9 becomes a plus 9. If I am doing a box, I have x squared. I'm going to split my negative 6x as a negative 3x and a negative 3x. So that means this is going to be an x minus 3 and an x minus 3. So this missing piece up here should have been a 9. So a positive 9. So I'm going to add 9 here and I'm going to add 9 here. So now this side is going to be x minus 3 squared equal 18. I square root it. I get x minus 3 is equal to plus or minus the square root of 18, which isn't a perfect square, but it is a 9 times a 2. So I can rewrite that as 3 root 2. And then my last step is to add the 3. And so I get 3 plus or minus 3 root 2. On B, I'm going to keep my x squared here. I'm going to minus 4x and I'm going to add the 1 to the other side. And then I am trying to get a perfect square. So I have x squared. My negative 4x is a negative 2x and a negative 2x. So that means I'm going to have an x minus 2, x minus 2. And what's missing here is a 4. So I'm going to add 4 here. I'm going to add 4 here. So I am going to get x minus 2 squared is equal to 5. I'm going to take the square root. So I get x minus 2 is equal to plus or minus root 5. I'm going to add 2. So I get 2 plus or minus root 5 as the answer. Okay. On number 6, we're looking at this to decide which expressions, it says determine if each expression is equivalent to the length of AC. Okay, so this is AC here. Okay. Now, if I am working this out, okay, so let me just write out tangent of A is going to be opposite over adjacent. Tangent of B is going to be from B, my opposite's now 3, my adjacent's now 4. Cosine of A, from A, my cosine is going to be 3 over, and I need to find my hypotenuse. I'm going to do Pythagorean theorem, but this is a 3, this is a 4, this is going to be a 5. It's a 3, 4, 5 right triangle, but again, do Pythagorean. So this is going to be cosine of A over 3. And then my sine of B is going to be from B opposite over hypotenuse, which is again 3 over 5. Now, what you want to notice is that when I have the tangent of the two angles in a right triangle that are not the right angle, so this A and B are not the right angle, these are complementary angles, and you'll notice the tangents are reciprocals. When I take those two complementary angles and I find the cosine of one and the sine of the other, those are going to be equal. Now, I want to know what is equal to AC, and AC is 3. So if I'm looking at this first one here, this one here, I am going to be taking this and I'm going to times it by 4. And when I do, I'm going to get 16 over 3, not the 3 that I want. This is what I want. That's what I want. It's not what I'm going to get. So this is a no. When I'm doing tangent of b times 4, so I'm going to times this by 4, those 4's cancel out. I do get a 3, so this is a yes. When I multiply cosine of a by 5, you see those are going to cancel out and I get a 3, so this is a yes. When I do sine of b by 5, you'll see that these cross out. I do get a 3, so this is a yes. On number 7, I've got parallel lines. So this line here and this line here are parallel. And they're cut by this transversal right here. Okay. Now, what's going to be true is this 25 degrees and this x, these are corresponding angles. So that means that x is going to be 25 degrees. Okay, so this is 25 degrees. Now, if I am looking at my 94 here, if I am looking at this as my transversal this time, and I am looking at this 94 degrees, this and this are going to be 94 degrees. So my z is going to be 180 minus 94. And when I take 180 minus 94, I get 86. So this is going to be 86 degrees. Sorry. This is 94 degrees because they're corresponding. This is 86 degrees. So this is 86 degrees. Now, since that is 86 degrees, what I know is that this angle here, which is 96, and these two together are also going to be 86. So I am going to take 86. I'm going to take 86 and I'm going to subtract 25 and I'm going to get 61. So this is 61 degrees. On number 8, we're looking for the x-intercepts and the y-intercepts, and they want us to show work. So my y-intercept is kind of my easier one. So into the equation, I'm going to put 0 in for my x's, and I'm going to get y is equal to negative 20. So this is going to be 0, comma, negative 20. That is my y-intercept. Now my x-intercepts, I'm going to put 0 in for y, and I get 0 is equal to x squared minus x minus 20. I'm going to factor that, figure out what multiplies to negative 20 and adds to negative 1. And that's going to be a negative 5 and a 4. So I'm going to have x minus 5, x plus 4. And this is going to give me x equal 5. And this is going to give me x equal negative 4. And so my x-intercepts are going to be 5, comma 0 and negative 4, comma 0. On number 9, Tamara wants to figure out the height of a tree outside her home. Using her clinometer, she measures the slope angle from 30 feet away from the base of the tree. Okay, so we have a tree. And if we go 30 feet away from the base of the tree, she is standing here using her clinometer to measure the height of the tree. So if she's looking straight here and then to the top of this tree, and again, this tree is all the way to the top of it. We know that her eye level is 5.5 feet. So the distance from here to here is 5.5 feet. And we want to know how tall is the tree. So the whole entire tree is going to be from here to here. But first, what I'm going to do is find this, let's say I call it Y. Let's say I call it Y right there. Knowing that this is 30 feet, this is a right angle, and it says that this is a 62-degree angle. So I am going to use, let me just kind of get rid of all the rest of the screen so we can. So this is Y. Okay, so I have opposite and adjacent. So we are going to do tangent of 62 degrees is equal to Y over 30. I am going to times both sides by 30. So we are going to have 30 times tangent of 62 degrees is equal to Y. And then I need to remember that onto that, I'm going to be adding the 5.5. So 30 tangent of 62. So 30 times tangent of 62. And let me come and make sure that I'm in degrees because I'm in radians. Okay, so that makes more sense. 56.42. So this is going to be 56.42. And then I need to add the 5.5 onto it. So 56.42 plus the 5.5, I end up getting 61.92. That is the height of the tree. Feet, that's feet. And on number 10, these ones we are factoring, and we're factoring completely. So the very first thing I'm going to do is I'm going to look at each term, and I notice that I can take a 2 out of each of them. The 2 is not going to be divided out, it's factored out, it's still there. And this is going to be a 6k squared plus k minus 15. So I am going to do a box to diamond. And I am going to have my 6k squared here, my negative 15. That's going to be a negative 90k squared, has to add to k. So that's going to be a 10k and a negative 9k. 10k and a negative 9k. And the first thing I'm going to worry about is getting that 6k squared. And that could either be a 6k and a k or a 3k and a 2k. Since 6 isn't going to 10 or 9, it is going to be a 2k helping get the 10 and a 3k helping get the 9. Minus 3 here, plus 5 here. So my factors, I have the 2 out in front, this 2 up here. Then I'm going to get a 2k minus 3, a 2k minus 3, and a 3k plus 5. And that's my factors. Now on B, again, can I factor something out of both of these? I can factor out a 2 again, and I'm going to get a 4x squared minus 9. Now this is a difference of 2 squares. So I have my 2, then my 4x squared minus 9 is going to be a 2x plus 3 and a 2x minus 3. And those are our factors. On C, in this case, I noticed that if I'm looking at my 5, my 15, my 20, negative 20, I can pull out a 5 from each of those. Now, looking at my x to the 4th, x to the 3rd, x to the 2nd, I can pull out an x squared from each of those. And then looking at the y, the y, the y, I can take a y from everything. And from my first term, I'm going to be left with an x squared. From my second term, I'm going to be left with a 3x. My last term, I'm going to get a negative 4. And if I'm looking at this, what multiplies to a negative 4 and adds to 3? That's a 4 and a negative 1. So I'm going to have 5x squared times y, then x plus 4, x minus 1, and that's our answer. And that's the end of this video.